Phase loss, also known as single phasing, can severely damage three-phase motors. Several methods exist to protect motors from this condition. These include phase loss monitors, phase reversal protectors, contactors with anti-single phasing protection, and three-phase monitoring relays. A basic phase loss monitor, such as the Timemark number 258, detects the absence of any single phase and trips the motor. A more advanced phase loss and phase reversal monitor, such as the Timemark number 2644, provides additional protection against incorrect phase sequencing. Phase reversal protectors, such as the Red Lion Controls Nemesis 1 phase reversal protector, protect against phase reversal, which can damage motors and affect their performance. A combination contactor and protection module, such as the Eaton Cutler Hammer CL5 contactor with anti-single phasing module, is designed to prevent single phasing by disconnecting the motor if any phase is lost. Three-phase monitoring relays, such as the Chint NE8P series, monitor phase voltage imbalances and missing phases. Another three-phase monitoring relay, the Carlo Gavazzi RW4 series, provides protection against phase loss, phase reversal, and phase imbalance. Timemark number 258 is well established and widely used for its reliability. The Chint NE8P series is known for its accuracy and durability. The Chint NE8P series offers a competitive price while maintaining high quality. The Eaton Cutler Hammer CL5 contactor provides both contactor and anti-single phasing protection in a single package. Phase loss monitors and relays are relatively easy to install, while contactors with anti-single phasing protection require additional wiring and expertise. Some relays may require periodic testing or calibration. Choose a device with adjustable sensitivity to avoid false tripping or missing critical phase issues. For reliable and cost-effective phase loss protection, either the Timemark number 258 or Chint NE8P series 3-phase monitoring relay would be suitable options. If phase reversal protection is also desired, the Timemark number 2644 or Red Lion Controls phase reversal protector should be considered. When selecting a phase loss protection method, consider the following factors: firstly, reliability; secondly, cost effectiveness; thirdly, installation difficulty; fourthly, maintenance requirements; and fifthly, sensitivity. Reliable phase loss protection is crucial for preventing motor damage and downtime. Cost-effective solutions balance protection with budget constraints. Easy installation minimizes labor costs and potential errors. Low maintenance reduces long-term operational expenses. Adjustable sensitivity prevents false tripping while ensuring effective protection. Here is an overview of the discussed protective devices. Firstly, Timemark number 258, a basic phase loss monitor known for its reliability and wide usage. It detects the absence of a single phase and trips the motor. Secondly, Timemark number 2644, an advanced monitor that detects phase loss and phase reversal, providing additional protection against incorrect phase sequencing. Thirdly, Red Lion Controls Nemesis 1 phase reversal protector. It protects against phase reversal which can damage motors. Fourthly, Eaton Cutler Hammer CL5 contactor with anti-single phasing module, a combination contactor and protection module that prevents single phasing by disconnecting the motor. Fifthly, Chint NE8P series 3-phase monitoring relay, a cost-effective relay that monitors phase voltage imbalances and missing phases. Sixthly, Carlo Gavazzi RW4 series 3-phase monitoring relay, a high-accuracy relay that protects against phase loss, phase reversal, and phase imbalance. These devices offer varying levels of protection and features, so it is important to choose the one that best suits the specific needs and budget. Before diving into the specific products and solutions, it's essential to understand the fundamentals of phase loss and its impact on three-phase motors. A three-phase motor is designed to operate with balanced voltage and current across all three phases. When one of the phases is lost, the motor attempts to continue operating on the remaining two phases, leading to several detrimental effects. Firstly, increased current. The motor draws significantly higher current from the remaining phases to compensate for the lost phase. This increased current causes excessive heating of the motor windings, which can quickly lead to insulation breakdown and motor failure. Secondly, reduced torque. The motor's torque output is significantly reduced. This can cause the motor to stall, especially under load, further exacerbating the overheating problem. Thirdly, voltage imbalance. The loss of a phase creates a voltage imbalance in the system, which can affect other equipment connected to the same power supply. This imbalance can cause reduced performance and premature failure of other motors and electrical components. Fourthly, backfeeding. If the motor is still rotating when a phase is lost, it can act as a generator and backfeed voltage into the disconnected phase. This can create hazardous conditions and damage other equipment connected to the circuit. Given these potential problems, it is clear that phase loss protection is a critical requirement for any three-phase motor installation. Now, let's take a closer look at the different types of protection methods available. Phase loss monitors are designed to detect the absence of any one of the three phases. These monitors typically work by continuously monitoring the voltage on each phase. If the voltage on any phase drops below a certain threshold, the monitor trips a relay which then disconnects the motor from the power supply. Phase loss monitors are relatively simple devices, making them cost-effective and easy to install. However, they only protect against phase loss and do not provide protection against other power quality problems such as phase reversal or voltage imbalance. Phase reversal protectors are specifically designed to protect against the accidental reversal of two phases. Phase reversal can occur during initial installation or after maintenance work. If the phases are reversed, the motor will rotate in the opposite direction, which can damage the driven equipment or create hazardous conditions. Phase reversal protectors typically work by monitoring the phase sequence. If the sequence is incorrect, the protector trips a relay, preventing the motor from starting or shutting it down if it is already running. Contactors with anti-single phasing protection combine the functionality of a standard motor contactor with phase loss protection. These devices typically include a built-in phase loss sensor that trips the contactor if a phase is lost. Contactors with anti-single phasing protection offer a convenient and compact solution for motor protection. However, they may be more expensive than separate phase loss monitors and contactors. Three-phase monitoring relays are more sophisticated devices that monitor a variety of power quality parameters, including phase loss, phase reversal, voltage imbalance, overvoltage, and undervoltage. These relays typically offer adjustable settings, allowing you to customize the protection to meet the specific needs of your application. Three-phase monitoring relays provide comprehensive motor protection, but they are also more expensive and complex to install than simpler phase loss monitors. When selecting a phase loss protection method, it is important to consider the specific requirements of your application. For simple applications where only phase loss protection is required, a basic phase loss monitor may be sufficient. For more critical applications where phase reversal or voltage imbalance protection is also needed, a three-phase monitoring relay may be a better choice. It is also important to consider the cost, installation complexity, and maintenance requirements of each option. Now, let's delve into some additional considerations for selecting the right phase loss protection. Sensitivity adjustment is a crucial feature to look for in phase loss monitors and relays. Adjustable sensitivity allows you to fine-tune the device to avoid false tripping due to minor voltage fluctuations, while still providing effective protection against genuine phase loss events. Setting the sensitivity too high may result in nuisance tripping, which can disrupt operations unnecessarily. Setting it too low may delay the tripping response, potentially allowing the motor to operate in a single phasing condition for a prolonged period, increasing the risk of damage. Installation and wiring requirements vary depending on the type of protection device. Basic phase loss monitors are typically easy to install, requiring only a few simple wiring connections. Contactors with anti-single phasing protection may require more extensive wiring, especially if they include additional features such as overload protection or remote control capabilities. Three-phase monitoring relays often have the most complex wiring requirements, as they need to be connected to multiple voltage and current signals. Proper wiring is essential for ensuring the correct operation of the protection device. Incorrect wiring can lead to false tripping, failure to trip, or even damage to the device or the motor. Therefore, It is important to carefully follow the manufacturer's instructions and consult with a qualified electrician if needed. Maintenance requirements for phase loss protection devices are generally minimal. However, it is recommended to periodically test the devices to ensure that they are functioning correctly. This can be done by simulating a phase loss condition and verifying that the device trips as expected. Some three-phase monitoring relays may also require periodic calibration to maintain their accuracy. The testing and calibration procedures should be performed by a qualified technician using appropriate test equipment. Another important consideration is compliance with relevant standards and regulations. In many jurisdictions, electrical installations must comply with the National Electrical Code, NEC, or other similar codes. These codes may specify requirements for motor protection, including phase loss protection. It is important to ensure that the selected protection device meets the applicable code requirements. Here is a step-by-step process for selecting and installing phase loss protection. Firstly, assess the application, determine the specific requirements for motor protection, including the type of protection needed, the voltage and current ratings, and any applicable code requirements. Secondly, evaluate the options, compare the different types of phase loss protection devices available, considering their features, performance, cost, and installation complexity. Thirdly, select the device, choose the device that best meets the needs of the application. Fourthly, install the device, follow the manufacturer's instructions carefully to install the device correctly. Fifthly, test the device. After installation, test the device to ensure that it is functioning correctly. Sixthly, maintain the device, perform periodic maintenance to ensure that the device continues to operate reliably. In addition to the specific protection devices discussed earlier, there are also some general best practices for motor protection that should be followed. Firstly, use properly sized conductors. Ensure that the conductors supplying power to the motor are properly sized to carry the motor's full load current. Undersized conductors can cause voltage drop, which can reduce motor performance and increase the risk of overheating. Secondly, use properly sized overcurrent protection devices. Install overcurrent protection devices, such as fuses or circuit breakers, to protect the motor from overloads and short circuits. The overcurrent protection devices should be sized according to the motor's nameplate ratings and the applicable code requirements. Thirdly, provide adequate ventilation. Ensure that the motor has adequate ventilation to dissipate heat. Overheating is a major cause of motor failure. Fourthly, perform regular maintenance. Inspect the motor and its associated components regularly to identify and correct any potential problems before they lead to failure. Regular maintenance should include cleaning, lubrication, and inspection of wiring connections. Let's also consider the economic benefits of investing in phase loss protection. While the initial cost of phase loss protection may seem like an additional expense, it can provide significant long-term savings by preventing motor damage and downtime. Motor repairs can be costly, especially for large motors. Downtime can also be expensive, as it can disrupt production and lead to lost revenue. By protecting motors from phase loss, you can reduce the risk of these costly events and improve the overall reliability and profitability of your operations. In addition to the direct economic benefits, there are also some indirect benefits to consider. Firstly, improved safety. Phase loss can create hazardous conditions such as overheating and voltage imbalances. By protecting motors from phase loss, you can improve the safety of your workplace. Secondly, reduced environmental impact. Motor failures can lead to the release of harmful substances such as oil and refrigerant. By preventing motor failures, you can reduce the environmental impact of your operations. Thirdly, enhance reputation. By investing in motor protection, you can demonstrate your commitment to quality, reliability, and sustainability, which can enhance your reputation with customers, employees, and other stakeholders. Finally, let's discuss some advanced phase loss protection techniques. Advanced techniques include the use of sophisticated monitoring algorithms and communication protocols. These algorithms can detect subtle changes in voltage and current patterns that may indicate an impending phase loss event. Communication protocols, such as Modbus and Ethernet, allow the protection devices to communicate with other control systems, providing real-time monitoring and control capabilities. Advanced phase loss protection techniques can provide even greater levels of protection and reliability. However, they are also more expensive and complex to implement. When deciding whether to use advanced techniques, it is important to carefully weigh the costs and benefits. In conclusion, phase loss protection is a critical requirement for any three-phase motor installation. By understanding the different types of protection methods available and following best practices for motor protection, you can significantly reduce the risk of motor damage and downtime, improve the safety of your workplace, and enhance the reliability and profitability of your operations. The specific choice of protection method will depend on the specific requirements of your application, but the investment in phase loss protection is almost always a worthwhile one. Remember to consult with qualified electricians and engineers to ensure that your motor protection system is properly designed and installed.